below, in this lecture, we will find the value of DE. In the drawing, we have triangle ABC. We know that AC equals to 2 units. We also know that BC equals to 8 units. And we know that DE is parallel to AB. And we also know that the size of DE is a number that is a natural number, and we know that point G is the centroid of triangle ABC. The centroid of any triangle is the point where the three medians are intersect with each other, and we want to find out the value or the size of line segment DE. So first of all, we have a rule, I will call it rule number 1, that relates to the centroid of a triangle. According to rule 1, the centroid of a triangle divides the median in a ratio that equals to 2 to 1. So I will read rule number 1 again. Rule number 1 states that the centroid of a triangle divides the median in a ratio that equals to 2 to 1. So actually, we know that G is the centroid of triangle ABC and CF is the median. What is the median? The median actually divides the side that it eats into equal parts. That is to say, the median CF divides AB to 2 equal parts, or CF bisects BC, or divides BC, or CF divides the side AB of triangle ABC into 2 equal parts. That is to say, AF equals to FB. Okay, AF equals to FB. So actually, according to rule number 1, the centroid G, this centroid, divides the median CF in a ratio that equals to 2 to 1. That is to say that if CG equals to 2 units, then GF will be equal to 1 unit. Okay? And you can also say that CG is twice as large as GF. Okay, so CG equals 2 times GF. CG equals to 2 times GF. So actually, if we define CG as 2x, that is to say CG equals to 2x, then we will substitute CG by 2x. We will get that 2x equals to 2 times GF. Then we will divide this equality by 2 and we will get that GF equals to x. So we actually found that if CG equals to 2x, then GF will be equal to x. Again, if CG equals to 2x, then GF equals to x. Okay? Okay, if CG equals to 2x, then GF equals to x. And actually we have another rule. I will call it rule number 2. Rule number 2 is true in any triangle. So I'll write here in any triangle. So if we have triangle ABC, that could be any triangle. And we know that line segment DE is parallel to BC. Again, line segment DE is parallel to BC. So in this case, if DE is parallel to BC, according to rule number 2, AD over DB, AD over DB will be equal to AE over EC. Okay? Again, in triangle ABC, that could be any triangle. If we know that line segment DE is parallel to BC, then the following equality is true, that AD over DB equals to AE over EC. And we actually can implement rule number 2 in our drawing, because in our drawing we know that DE is parallel to AB. We know that DE is parallel to AB. It is given us in the question. DE is parallel to AB. Therefore, if we relate to triangle ACF, if we relate to the green triangle ACF, in the green triangle, triangle ACF, because of the fact that DE is parallel to AB, according to rule number 2, CD over DA will be equal to CG over GF. Again, in the green triangle, triangle ACF, we know that DE is parallel to AB, therefore, according to rule number 2, CD over DA will be equal to CG over GF. Okay, that is according to rule number 2. Okay, in the green triangle, we know that DE is parallel to AB, therefore CD over DA will be equal to CG over GF. But what is the value of CG? The value of CG equals to 2x. And what is the value of GF? GF equals 2x. So we got that CD over DA equals to 2x over x. X over x is 1, so x will get cancelled. So what is left is 2. We got that CD over DA equals to 2. And if we multiply this equality by DA, we will get that CD equals to 2 times DA. CD equals to 2 times DA. So actually, if we define CD as 2y, that is to say CD equals to 2y according to our definition, then we can substitute CD by 2y in this equality, and we will get that 2y equals to 2 times dA. Then we will divide this equality by 2, and we will get that dA equals to y. So actually we found out that if CD equals to 2y, then dA will be equal to y. So I will write it down. If CD equals to 2y, then dA will be equal to y. Okay? So actually we have another rule, we call it rule number 3. Rule number 3 states that corresponding angles in between parallel lines are equal to each other. I'll write it down. Corresponding angles between parallel lines are equal to each other. Now I will read rule number 3 again. Rule number 3 states that corresponding angles between parallel lines are equal to each other. Okay, so actually we can implement rule number 3 in our drawing, because in our drawing we know that line segment DE is parallel to AB. Line segment DE is parallel to AB. So we have two parallel lines. Therefore, according to rule number 3, the two corresponding angles will be equal to each other. Those two corresponding angles that are located between the parallel lines DE and AB will be also equal to each other. Okay, so actually angle BAC will be equal to angle BDC. That is according to rule number 3. Again, angle BAC will be equal to angle BDC according to rule number 3, because those two angles are corresponding angles that are located between the parallel lines DE and AB, therefore they will be equal to each other. And if we define one angle as alpha, then the other angle will be also equal to alpha, because they are equal to each other. Okay, so angle BAC equals to angle BDC, and both those angles are equal to alpha. That is according to rule number 3. And the same thing is true on the other side of triangle ABC. On the other side of triangle ABC, we have those two corresponding angles that are located between the parallel lines DE and AB. So those two corresponding angles that are located between the parallel lines DE and AB will be equal to each other according to rule number 3. So we can write down that angle ABC, this angle will be equal to angle DEC according to rule number 3. Angle ABC equals to angle DEC according to rule number 3, because of the fact that those two corresponding angles are located between the parallel lines DE and AB, therefore according to rule number 3 they are equal to each other. So if we define one angle as beta, if angle ABC equals to beta, then angle CED will be also equal to beta. Okay, so angle ABC equals to angle DEC, and both angles are equal to beta. Okay, so we actually found out that those two angles are equal to each other, they are both equals to alpha, and those two angles are also equal to each other, they are both equal to beta, and that is according to rule number 3, that states that corresponding angles between parallel lines are equal to each other. We have those two corresponding angles and those two corresponding angles that are located between the parallel lines DE and AB, therefore they are equal to each other. So those two angles are both equal to alpha, and those two angles are both equal to beta. Okay, so in the next step we will focus on two triangles, on triangle ABC, the big triangle, triangle ABC, and the small triangle, triangle CDE, and we actually will prove that those two triangles are similar to each other. So we will focus on the big triangle, triangle ABC, and the small triangle, triangle CDE. Again, we will prove that those two triangles are similar to each other. Again, we will focus on triangle ABC and triangle CDE. So actually, we know that angle BAC on triangle ABC is equal to angle CDE on triangle CDE. And they are both equal to alpha. Okay? Angle BAC from triangle ABC equals to angle CDE of triangle CDE, and they are both equal to alpha. We also know that angle ABC, this angle from triangle ABC, is equal to angle DEC from triangle CED, and they are both equal to beta. Again, angle ABC equals to angle DEC, and they are both equal to beta. And the third angle, actually this angle, angle C, this angle C is a common angle because it belongs both to triangle CDE, and angle C also belongs to the big triangle, triangle ABC. So we can write down that angle C equals to angle C it is actually a common angle. It belongs both to triangle ABC and to triangle CDE. It is a common angle. Again, angle C equals to angle C. It is a common angle. It belongs to both triangles. So we actually proved that the three angles of triangle ABC are equal to the three angles of triangle CDE. So actually we can say that triangle ABC is similar to triangle CDE according to angle similarity rule. So I will write it down. Triangle ABC is similar, that is the sign of similar, to triangle CDE according to angle similarity rule. Again, the big triangle, triangle ABC, is similar to triangle CDE according to angle similarity rule. So what is angle similarity rule? If you prove that all the three angles of triangle ABC are correspondingly equal to all the angles. If you prove that all the angles of one triangle are correspondingly equal to all the angles of the other triangle, you actually proved that those two triangles are similar to each other according to angle similarity rule. Okay? So, from the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC CD is the side that belongs to triangle CDE, and AC is the side that belongs to triangle ABC. CD over AC equals to DE over AB. Again, DE is the side that belongs to triangle CDE, and AB is the side that belongs to triangle ABC. Okay, so the following relationship is true for the two similar triangles, triangle ABC and CDE. CD over AC equals to DE over AB. Okay, but what is the value of CD? CD, as you can see, CD equals to 2y. And what is the value of CA? CA equals to CD plus DA. So CA equals to CD that is 2y plus DA that is y. So 2y plus y. The value of CA is 2y plus y. So in total we got that two y plus y equals to DE over AB, or 2y over 3y equals to DE over AB. Here y over y is 1, so y will get cancelled, and what is left after y get cancelled? We left only with DE over AB that equals to 2 over 3. Here we will multiply this equality by AB, and we will get that DE equals to 2/3 AB. So we found out that DE equals to 2/3 AB. Okay, so in the next step I will present to you a new rule number 4, that is true in any triangle. So in any triangle, the sum of two sides is always greater than the length of the third side. The sum of two sides of any triangle is greater then the length of the third side I read the rule again. Actually, it is the first part of rule number 4. The first part of rule number 4 states that the sum of two sides of any triangle is always greater than the length of the third side. So actually, if we have a triangle ABC that could be any triangle, again, triangle ABC could be any triangle, and we know that the size of side AB of triangle ABC equals to A units, and the size of side AC of triangle ABC equals to B units, and the size of side BC of triangle ABC equals to C units. Then, according to the first part of rule number 4, the size of two sides of triangle ABC, that is to say A plus B will be greater than the length of the third side, that is to say will be greater than the length of the third side is actually BC equals to C units. A plus B is greater than C. A plus B is greater than C. Again, the sum of two sides of the triangle, that is A plus B, is always greater than the length of the third side, that is to say is greater than C, because C is the length of the third side, that is BC. The length of BC is C units, so the sum of two sides of the triangle, that is A plus B, is greater than the length of the third side, that is to say A plus B is greater than C. Okay, that is the first part of rule number 4, and the second part of rule number 4 is that the difference between the two sides of any triangle between two sides of any triangle is always smaller than the length of the third side. So I will read the second part of rule number 4 again. The difference between two sides of any triangle is actually always smaller than the length of the third side. That means that actually here the difference between the two sides of triangle ABC is A minus B, and the difference between the two sides of triangle ABC is always smaller than the length of the third side, and the length of the third side is C. C is always bigger than the difference between the two sides of the triangle, that is A plus B. It is actually the difference or the absolute value of the difference between two sides of any triangle is always smaller than the length of the third side. Okay, so actually here it is a difference between the absolute value of two sides of any triangle is smaller than the length of the third side. So you can write here that the difference between two sides of any triangle, when I say the difference between the two sides, I actually mean to the absolute value. To the absolute value of the difference, because if B is bigger than A, then A minus B will be a negative number. Therefore, we must take the absolute value of the difference. Okay, so actually this inequality is the summarization of rule number 4, because it actually states that the sum of two sides of the triangle ABC is bigger than the length of the third side. That is to say, A plus B is bigger than C. That is the first part of rule number 4. A plus B is bigger than C. And the second part states that the difference between two sides of triangle ABC, that is to say A minus B, or the absolute value of the difference, is always smaller than the length of the third side. That is to say, A minus B, or the absolute value of A minus B, is smaller than the length of the third side, that is actually C. Okay, so in this inequality we actually summarize rule number 4. Okay, so we actually can implement rule number 4 in our triangle ABC. Again, it could be any triangle. Triangle ABC could be any triangle. So here, if we relate to our triangle ABC, to side AB of triangle ABC, according to rule number 4, side AB of triangle ABC will be smaller than AC plus CB from one side, AC plus CB. So the size of AB will be smaller than AC plus CB from one side, according to rule number 4, but from the other side, AB will be bigger than AC minus CB, or the absolute value of AC minus CB. Again, the second part of rule number 4 states that AC will be bigger than the absolute value of AC minus CB. Okay, so this inequality is the implementation of rule number 4 in our triangle ABC. Okay, but we know that AC equals to 2 units and CB equals to 8 units. So AB will be smaller than 2 plus 8 because AC equals to 2 and BC equals to 8 from one side, but from the other side AB will be greater than the absolute value of AC, that is 2 minus CB, that is 8. So AC will be greater than the absolute value of 2 minus 8. And the absolute value AB is greater than the absolute value of minus 6, and it is smaller than 2 plus 8, that is 10. Okay? And what is the absolute value of any number? The absolute value of any number is the distance of the number from 0. So the distance of minus 6 from 0 is 6 units. Therefore, the absolute value of minus 6 is 6. So AB will be greater than 6 for one side, but it will be smaller than 10. So we have the inequality that states that AB is bigger than 6 and smaller than 10. But we have already found out that DE equals to 2/3 AB. DE equals to 2/3 AB. We have already found out that DE equals to 2/3 AB. So here we will multiply this inequality by 2/3. And we will get that 2/3 AB, it is bigger than 2/3 times 6, and it is smaller than 2/3 times 10. Okay? Two-thirds times 6 is 2 times 6 is 12, and 12 over 3 is 4. So we get that 2/3 AB is greater than 4 for one side, but it is smaller than 2 times 10 is 20, is 20 over 3 is 6.66. 6.66. Okay, so we actually found out that 2/3 AB equals, it is greater than 4 and it is smaller than 6.66. But we know that DE equals to 2/3 AB, so we can substitute 2/3 AB by DE. Okay, so we'll do it now. We'll substitute 2/3 AB by DE because DE equals to 2/3 AB. We will get that DE is greater than 4 and it is smaller than 6.66. So here we substituted 2/3 AB by DE, and we got that DE is greater than 4 and it is smaller than 6.66, but it is given us in the question that DE belongs to the natural numbers. That is to say, DE is a natural number. We know that the size of DE is a number that is natural number. DE belongs to the natural numbers. So actually, which natural numbers we have that are greater than 4 and smaller than 6.66? Actually, we have only two natural numbers that satisfy this requirement. So we'll get that DE equals to either 5 units or 6 units. Okay? DE equals to either 5 units or 6 units, and that is the answer to the question that the size of DE, the size of line segment DE, will be will be either equal to 5 units or it will be equal to 6 units. Okay, that is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the size of DE, the size of line segment DE. We know that the size of CA in triangle ABC is 2 units, the size of side CB in triangle ABC is 8 units, and we also know that line segment DE is parallel to AB, and again we know that DE belongs to the natural numbers. That is to say, the size of DE is a number that is a natural number, and we also know that point G, this point is the centroid of triangle ABC. What is the centroid of any triangle? The centroid of any triangle is a point where the three medians of the triangle are intersect with each other. So at this point, point G, the three medians of triangle ABC intersect with each other. Okay, and we actually have a rule that relates to the centroid of any triangle. The rule states that the centroid of a triangle divides the median in a ratio that equals to 2 to 1. That is to say, the centroid, we know that CF is the median of triangle ABC. Why CF is the median of triangle ABC? Because of the fact that it passes for point G. What is the median of any triangle? The median of any triangle bisects the side that it eats. CF eats side AB, CF eats side AB of triangle ABC, therefore it bisects it. That is to say, AF equals to FB, or CF divides side AB to 2 equal parts. That is to say, AF equals to BF. So according to rule number 1, the centroid G divides the median G, the centroid G divides the median CF in a ratio that equals to 2 to 1. That is to say, if CG equals to 2 units, then GF will be equal to 1 unit. Okay? If CG equals to 2 units, then GF will be equal to 1 unit, or in other words, CG is twice as large as GF, according to rule number 1. CG equals to 2 times GF. Okay, and if we define CG as 2x, that is to say CG equals to 2x, then we can substitute CG by 2x. Okay, we will get that 2x equals to 2 times GF. Here we will divide this equality by 2, and we will get that GF equals to x. So we found out that if CG equals to 2x, then GF will be equal to x. So we can write here that if CG equals to 2x, then GF will be equal to x. Okay, and we also have another rule, rule number 2. Rule number 2 is true in any triangle. Rule number 2 states that if in triangle ABC, that could be any triangle, we know that line segment DE is parallel to BC, then the following equality is true, that AD over DB will be equal to AE over AC. Again, in triangle ABC, that could be any triangle. If we know that line segment DE is parallel to BC, then AD over DB will be equal to AE over EC. And we can implement this rule number 2 in our triangle, because in our triangle we know that line segment DE is parallel to AB. So according to rule number 2, if we relate to the green triangle, triangle CAF or ACF, again, in our drawing we know that DE is parallel to AB. It is given us in the question. So if we relate to the green triangle, triangle ACF, according to rule number 2, CD over AD will be equal to CG over GF. Again, in triangle, the big triangle, in the green triangle, triangle ACF, we know that DE is parallel to AB. Therefore, according to rule number 2, CD over DA will be equal to CG over GF. Okay, CD over DA will be equal to CG over GF. But what is the value of CG? CG equals to 2x. So CG equals to 2x. And what is the value of GF? The value of GF is x. So we can write here that GF equals to x and CG equals to 2x. We got that CD over DE equals to 2x over x. X over x is 1. So x will get cancelled, and we left only with CD over DE, CD over DA equals to 2. So CD over DA equals to 2. Here we will multiply this equality by DA, and we will get that CD equals to 2 times DA. CD equals to 2 times DA. So CD is twice as large as DA. So if we define CD as 2y, that is to say CD equals to 2y according to our definition, then we'll get that 2y equals to, we can substitute CD by 2y, or CD equals to 2y, so 2y equals to 2 times DA. Here we will divide this equality by 2, and we will get that DA equals to y. So we actually found out that if CD equals to 2y, then DA equals to y. So here we can write down that if CD, here CD equals to 2y, then DA will be equal to y. Okay, then we have rule number 3 that states that corresponding angles between parallel lines are equal to each other. And we can implement rule number 3 in our drawing, because in our drawing we have two corresponding lines. Line segment DE is parallel to line to AB. DE is parallel to AB, therefore according to rule number 3, those two corresponding angles that are located between the parallel lines DE and AB will be equal to each other. That is to say, angle BAC will be equal to angle BDC according to rule number 3. And if we define one angle as alpha, then the other angle will be also equal to alpha, because those two angles are equal to each other. So angle BAC equals to angle BDC equals to alpha. And in the same way, we can say that those two corresponding angles will be also equal to each other, because of the fact that those two corresponding angles are located between the parallel lines DE and AB. Therefore, according to rule number 3, they will be equal to each other. That is to say, angle ABC equals to angle DEC, because those two corresponding angles are located between the parallel lines DE and AB. And if we define one angle as beta, then the other angle will be also equal to beta, because those two angles are equal to each other. So angle ABC equals to angle DEC, and they are both equal to beta. So those two equalities, we found those two equalities according to rule number 3. Those two equalities are true according to rule number 3. That those two angles are both equal to each other, and they are both equal to alpha, and those two angles are also equal to each other, and they are both equal to beta. Okay? Then we actually focused on triangle ABC, the big triangle, and triangle DEC, and we proved that the big triangle ABC is similar to the small triangle, triangle DEC. Again, we focused on triangle ABC and triangle CDE, and we proved that those two triangles are similar to each other. First of all, we know that angle BAC equals to angle CDE, and they are both equal to alpha. Those two angles are equal to each other, and they are both equal to alpha. And we also know that angle ABC equals to angle DEC, and both those two angles are equal to beta. Those two angles are equal to each other, and they are both equal to beta. And the third angle, this angle, angle C, it is actually a common angle, because of the fact that it belongs both to the small triangle, triangle CDE, and angle C also belongs to the big triangle, triangle ABC. So we can write down that angle C equals to angle C as a common angle. So we actually proved that the three angles of triangle ABC are equal to the three angles of triangle CDE. Therefore, we actually proved that those two triangles, triangle ABC and triangle CDE, are similar to each other according to angle similarity rule. Triangle ABC is similar to triangle CDE according to angle similarity rule. And what is angle similarity rule? Actually, if you prove that the three angles of one triangle are correspondingly equal to the three angles of another triangle, it actually proved that those two triangles similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to triangle CDE, we can conclude that the following relationship exists between the sides of the two triangles. That is to say, CD over AC, CD over AC equals to DE over AB. Again, CD, the side of triangle CDE, over AC, that is the side of triangle ABC, is equal to DE, that is the side of triangle CDE, over AB, that is the side of triangle ABC. Again, CD over AC equals to DE over AB. Okay? And what is the size of CD? The size of CD is 2y. Okay, so CD equals to 2y. And what is the size of CA? CA actually equals to CD plus DA. And CD is 2y and DA is y. So CA in total equals to 2y plus y. Okay, so CD equals to 2y and AC or CA is equals to 2y plus y. So in total we got that DE over AB equals to 2y over 2y plus y is 3y. 2y over 3y is actually 2/3 because y will get cancelled. Y over y is 1. So y will get cancelled and we left only with the equality that says that DE over AB equals to 2/3. Here we multiply this equality by AB and we got that DE equals to 2/3 AB. Okay, DE equals to 2/3 AB. Then we have rule number 4 that states that in any triangle, rule number 4 is true in any triangle. In any triangle, the sum of two sides is greater than the length of the third side. That is to say, the sum of two sides is A plus B will be greater than the length of the third side, that is C. Or A plus B will be greater than C from one side, and the second part of rule number 4 is that the difference between two sides of any triangle is smaller than the length of the third side. So the difference between two sides of the triangle is A minus B will be smaller than the length of the third side, that is to say C. So A minus B will be smaller than C, or the absolute value of A minus B will be smaller than C. So this inequality summarizes the rule number 4. That actually rule number 4 states that A minus B is greater than C from one side, but from the other side the absolute value of A minus B will be smaller than C. Okay, so again we can implement rule number 4 in our drawing, because we have here triangle ABC. So if we relate to side AB in triangle ABC, we can write that AB is smaller than the sum of the two other sides, that is to say CA plus CB, or AC plus CB. AB is smaller than AC plus CB from one side, but AB from the other side is greater than CA minus CB, or the absolute value of CA minus CB, or AC minus CB, the absolute value of AC minus CB. That is actually the implementation of rule number 4 in our triangle ABC. But what is the value of AC? AC equals to 2 units and CB equals to 8 units. So we get that AB is greater than 2 plus 8, and it is AB is greater than, AB is smaller than 2 plus 8 from one side, and from the other side AB is greater than the absolute value of 2 minus 8. AB is greater than 8 because 2 plus 8 is 10. AB is greater than, AB is smaller than 10 from one side, and from the other side AB is greater than the absolute value of minus 6. And what is the absolute value of minus 6? The absolute value of any number is the distance of the number from 0, and the distance of minus 6 from 0 is 6 units. So the absolute value of minus 6 is 6. So in total we got that AB is smaller than 10 and greater than 6. but we have already found out that DE equals to 2/3 AB. So we can write this equality that DE equals to 2/3 AB after that's what is that's what we have already found out. So here we will multiply this inequality by 2/3, and we will get that 2/3 AB equals to 2/3 times 2/3 AB is smaller than 2/3 times 10, and it is bigger than 2/3 times 6. 2/3 times 10 is 6.66, and 2/3 times 6 is 4. So we found out that 2/3 AB is smaller than 6.66 from one side, but it is bigger than 4. Okay, but we know that DE equals to 2/3 AB, so we can substitute 2/3 AB by DE because DE equals to 2/3 AB. So we got that after we substituted 2/3 AB by DE, we got that DE is greater than 4 and it is smaller than 6.66. Okay? But we know it is given us in the question that DE belongs to the natural numbers. That is to say, the size of DE is a number that belongs to the natural numbers. So which natural numbers are bigger than 4 and smaller than 6.66? Actually, we have only two natural numbers that satisfy this requirement. And the natural numbers are 5 and 6. So the final answer to the question is that the size of DE is either 5 units or 6 units. Okay? Thank you very much.